Hi everyone. I hope that we are full. My name is Vladislav Burtsev. I am an analyst for Trend Intelligence of Kaspersky Lab. And this warm Friday day in May, we're going to speak about old Microsoft technologies, DCOM, DCOM, and many other things. The agenda for today looks like that. First, we'll get from more general things to more specific things. So I will tell you about how technologies are structured, and I will tell you about more advanced capabilities, what utilities and these are being used in order to interact with it. So then I will tell you about two types of attacks that are using that technology, and these two types of technologies actually could be divided into the attacks with the direct use of COM, DCOM, and the attacks without the event-triggered execution, which is called COM hijacking. And at the end of the day, we'll share some approaches how to detect that and several rules that can be used in infrastructure. Let me start with the following. Some history lesson. The COM history was introduced in 1990s, and in essence, this happened 5 years after DDE technology, dynamic data interchange, was invented, and all these abbreviations such LEO, LTFX, DCOM, COM+, NTS, actually the list is not full. This is everything related to COM. COM actually is used in order to build everything in Windows. The problem, the complex of problems which resulted in the fact that COM was introduced, it cannot be described in simple terms, but I can draw an example. In Windows, we have DLL notion. Probably some of you learned about DLL. That's the citation when, just as an example, when certain process would run DLL, and this DLL would run another DLL, and it would depend on anything, and it may go in circles. It also may happen that the process would need A DLL, and this DLL would need B DLL, and this all has been actually very cumbersome, and Microsoft decided, so let's make a technology that the client would not even think of what versions are there. And where the server is, just the client engages a function and it would be delivered. This is what COM is about. In its basic option, COM is a kind of that thing. I'm speaking about COM, but I mean COM, ITCOM, and all I listed above, because they are different only where the objects are located. I will tell you more about that a bit later. So actually, I don't want to limit that with COM only. The basic terminology, which also is not very widely used, but COM class has been providing COM interface. Interface is a very simple thing, and you can consider that as a set of methods that you can use. And usually, actually, it would be a dash and zero and ring there. COM object as an instance of a COM class. In C++, we have some class of machines, and there are other cases. Some COM class, in essence, that's just a class. It has certain defining features. For instance, COM class could be identified using IDs, which is quite typical for Windows, and it would be ID class. And COM component, probably you do not see that on the slide. Otherwise, it could be called a COM server, and this COM component, the COM server, can interact with the client in two ways: inside the process and out of process. In process, everything goes on very simply. So the client's application would engage or would instance a COM object. It's been created within that process, and actually they communicate almost directly. Almost, because if there are people who work with that, they can ask reasonably that this is not always inside that object. There might be some proxy setups, etc. But let us keep that moment for simplicity. But again, I would get back to that if you're interested. This is just a general view. Outside the process, there might be the following thing. Outside the process means that not necessarily just another process, but this might be another host. The client would engage something, and an object would get back to that. So the client doesn't see any difference between those two options, but there is a difference. For instance, in case the object has been created within a process, the object would be created somewhere else along with the stub and along with proxy. Proxy would emulate a COM object and would marshal the data to stub, and stub would marshal the data to the real COM object, and so this is the way they communicate. Every COM object would provide an interface which is called IUnknown. That's a common denominator for all the COM objects. Why this is needed? This is needed just because this is the way you run the service time of an object, and in Windows the service life is defined by the number of links. That interface would give you three methods of query interface, which is needed in order to engage some more useful interface, then adding link and deducting the one or release. In case the number of links to the object is reduced to 0, the object would be destroyed, would be killed. This is how instancing of COM object goes on. Again, the client's application, which you can see in the upper part of the slide. The client's application, again, runs some function, and we will see later on what function it is, which will render the ID. Then this ID class would be received, and actually in the register it would look like that. There is hroot, and it has a key to LSID, and below that you can find a key with some specific quid, and in that key there might be some other keys, and among them there would be Internet Server 32. It might be Local Server 32 or anything like that, depending on the type. Most importantly, this shows what executable file has to be instanced. In that very case, this would be DDL, and Service Control Management would create a COM object and would get render the indication to it to the client. And this is most important for the client, and using that the client would engage certain methods. That was the case when we run that on one host, and when we run that on two hosts, then the situation would look much more interesting because there is an inter-network interaction between two hosts. And again, for the client, there is no difference. Where COM component is being engaged, is being invoked, because he would get back an object that would emulate this COM object for him. But what goes on there would be another request to the service control management, which then would go to certain other service of the remote host. That interface is called a remote activation. And if you look at its signature, you will see a lot of parameters. That's quite an interesting thing. And then the work would be done by the service control manager on the server host. It would instance the COM object and would return to the client the indicator to, how do I put that correctly? to what it can communicate to. So in that case, that would be interface. The protocol which is being used there, and again, let me describe. Any service control manager would provide an interface which is called iRemote activation and RPC. In case an object has been set up or created, it will be or RPC or object RPC. That's an example of how you launch a COM object. I got that from PowerShell Empire script. And you can immediately see the get type from CLSID. That's a variable name which says that the object of that class would be created on a different computer. And the class, which in essence, in that case, is a shell browser window, it might be any useful for the person who uses the script for the attack. And we see the method which is being used. So we have created an instance class, and we got an indication to the interface, and we have used a specific method from that interface. Here you see the examples from PowerShell Empire, what it does, where what they can be. It might be get up from class ID or from prog ID, shell window, MMC20, and anything like that. You can use any COM class which is being useful. You can use COM class Word in order to and in essence, actually, following the logic, it should not be there. COM classes were, in essence, designed to make convenient the communication between those objects on the slide. You can see an example of creating an instance of the same COM class in different programming languages. C#, PowerShell. We know they look similar. C, C++. Conventional VNAPI and Visual Basic for applications. It means that you can use macros from different Office applications as well. So we see certain functions which are needed in order to get connected to Internet. So it means that you can require something by means of that COM object. What happens in essence? What we mean by setting up an instance or COM class. In the eyes of the client, what goes? First of all, we initialize COM for the thread. So it would be put into some apartment, which might be uniflow or multiflow. For us, there is no difference if you're interested in that. You can ask a question, and again, this is not so important in terms of the security that we are considering. After we initialize COM, co-create instance might be engaged to create an instance of a given class and return a requested interface pointer to the new object. Where the interface within that function, the client may indicate a context. I do not know whether this is legible, whether you can read what is on my screen, but the context would show where we want to create a COM server. Do we want to do that inside the process? Do we want to make that a standalone process or on a remote host? Inside, there is a co-create instance that would initialize go-get class object. So this is done inside, and it is done to get a pointer to the iClass factory interface. The developers who have certain experience of dealing with Windows are familiar with the problem that you cannot just make a class in DLL so that the client could upload that and create an instance of that class. This is not very convenient. That's why, actually, you have to make some ways around, and it's being done by means of iClass factory, and that function gets a pointer to that factory, and after that it would create an instance class. So class factory usually creates some instances. The very function of go get class object may go one of the three ways, depending on how COM server is implemented. It might be DLL, exe, or service. And this would determine how it would be reflected in the registry. There would be the following ways. After actually you use DLL, then you will have to locate CLCISID, then the load DLL from in pros server 32 key, and then actually it would call DLL get class object, and it would return the class factory to caller. So more interesting things happen when you use the executable file. The first step would be not locating the registry, but rather some global table that is stored in VC host, which hosted in CVC host exe. This is the way you can map certain class of ID with what is associated with the class factory. And very rarely it happens that it is already in that table, so still you will have to serve the registry and run it. And it would be different from DLL. SVC host, by means of create process, would create a process out of that image. And another important thing, this process has to get registered within that global table. After registration, a pointer to the factory would be obtained. And the third option, the last one, that's an option when COM component is been executed as a service. It is not too much different from the executable file. The only difference is that you are using app ID key, and this would be only the service management that launches the function. But again, there are no privileges there. It has to get registered on the table, would get a pointer, etc. And Regis file 32 functions as registering the file. It would initiate load library, and then by means of get proc address would search for DLL register server, and that simple function within COM component is responsible for registering of the COM object there. All the records in the registry and other things which might be useful in the process of work. And this is all there. In case we speak about the reverse registration or on registration, there would be DLL on register, and it means that you have to check that box. A specific example again as how COMs are being used. This is AMCI, this is the pure COM. AMCI Windows, this is a COM object. This means that that's a DLL which would be uploaded to the PowerShell in any other process. That would trigger the processes on the right-hand side, and that DLL is a COM component. COM class will provide you with the anti-mallover method, and everything that has to be executed within PowerShell, virtual scripts host, and other things. And it helps, for instance, to make your MC provider and implement your method there. And along with the window one, you would scan what is being executed on the host. Let me share some examples as how it might be used in attacks. Again, there are two frameworks. In packet.com exec looks very scary. I'm not sure whether you can see that clearly, and still it looks not very legibly. Just Python is being used, and this is not the most convenient thing for interaction with COM. But to decipher that, there are attempts to make COM objects of MMC20 and to use that method in order to trigger the attacking method. And PowerShell Empire is below. And for instance, there are such methods at register XLL for COM object in Excel. And DNN initiate. There are several more examples which are not so popular then. Bits has its own COM object as well. It also may upload some data. And there is some peculiarity. Bits a background copy job. And that interface, there is a method set modified. That method which uploads using bits method. If you use these parameters, if you upload some script and then run CMD and get the result into WMST, then there will be no upscaling of the privileges, but an interesting process would emerge. Certainly, file script PS1 would be created, but along with that file, SVC host would launch CMD, and after that CMD would set up info.txt, etc. And that's a very interesting thing. Not only in terms of attacking, but in terms of looting, you have to pay attention to the fact that SVC house being launched, it can be done not only remotely, but also locally. A few words about the registry where it is all stored. HK classes root, this is not a typical branch, not a branch which does exist from the very outset. It consists of the information which varies from user to user. But if you try to describe what is there, there are three blocks of information. File extension associations, what extension should be opened with what software, COM class registrations, and virtualized registry root for UAC. UAC virtualization. This is a utility which enables old applications to record something. And in essence, in case of virtualization, everything actually would be recorded in H classes root. And there are some limitations. You cannot just up and do that. So it has to be 32-bit, and there are other limitations imposed by Microsoft. The registration itself, the COM class registration data, for instance, would consist of two things: registration for some specific user and registration for the system. That information is derived from HKLM software classes and also the HKCU software classes. That's a merge of two branches with different privileges for the user. Hence, we have several interesting attacking methods, which could be called COM hijacking. First of all, that's about abandoned COM keys. It may happen that some software is registering some COM object in the system, and then the software would be deleted, and this COM object is not unregistered. That's a case of not a deleted software, but just this is shown as an example. And the reference to a DLL is there, but there is no such a DLL object. If well, a criminal may just put a DLL there, instance a COM class, and make the code executed. If it is a privileged thing, then it would be privileged. But hence is a question. A more laconic method of hijacking. It is based on quite legitimate technology, emulation of other COM classes. This was done for the sake of reverse compatibility, and it is so convenient. Some class becomes obsolete, and you issue another one, and you make trade-s with a pointer to an old one, and it means that always a new one would emerge instead of the old one. It will be not only locally but also remotely as well. If you trigger thread S there, so the new key would be used. So Windows ignores any attempts to create this very object. One more thing which looks like what I spoke about before, it is called script-let URL, and sometimes it is added to the COM object. And when you create an instance, the Windows would go the way which is described there, and would execute script-let. So this is the self-explanatory slide. You see what is there. And the question is how you launch a COM class, how you create an instance COM class. And the answer to that question we can get very easily. You can get run DLL with an argument as a quid and the flag of, and there is a flag local server. And this is an example of the registry file, which is called Windows Archaeology, which allows you to make sure that this way of DLL hijacking really works. More modern things.
Это методы, я думаю, что все узнали, кто видел DCOM репозитории, это методы повышения привилегий.
This is the method of upscaling the privileges. And as you see, in terms of the type, we see the elevated COM interface. The very description indicates how it's all going on, and it's quite interesting. The factory, the class factory, works with upscaled or elevated privileges, and you can create an object that also would be elevated, and it may create scheduled tasks that could work from the system. And back to the interesting thing of detect. Let me share some approach. The first approach is based on event MC or 4405. When you just look at the combination of certain commands or commandlets. So that's a combination of several methods, and I give an example for Empire only, but if you research all the methods that you do not want to see in the infrastructure, which are providing COM classes, there will be many more of them, and the commands which are needed in order to create such a COM class. And we can use create instance, for instance, but this is just one of the options. Another thing, a ready-made rule Sigma format. I do hope that many of you are familiar with this format. It is convenient to transfer information from one another, and in that case, that's a rule for registry set, and it just makes sure that somewhere in KLS ID branch a TradeS key is created. And on average, Windows 10 has about 9.5 COM objects, so it means that there are a lot of opportunities there. So this area is not very well started yet, and they needed not only to interact with COM or anything like that. There are COM objects which are communicating to certification servers. There are COM objects which are communicating to COM directories. There are many other interesting things. And another rule, which is quite simple as well and quite clear, the use of random RL in order to instantiate the COM classes directly. Very rarely you can find that in real life. When certain software is doing that, that is being done legitimately, but as far as this is the most convenient way to create a COM object, the malicious agents are using that. I'm concluding my remarks, and thank you so much. Should you have any questions, most welcome. Thank you. Thank you for your report. So you told us about how COM is working, how we can detect that, but how we secure ourselves? Well, look, protection requires some complex approaches on the one hand. This is about the detection rules. On the other hand, this is prevention in terms of some settings in the network. Then some security solutions. I told you about the detecting rules, and there are many of them. I'm not ready to give a full list, but one of them is when we have COM users. You can look at that. Such things as access to COM servers, personalizing that access, and delegation of rights. Can this be used to provide protection? Well, Microsoft are there solutions that enable us to do that conveniently and automatically? Well, never heard about anything like that, but really that would be very interesting to look at how some COM object is being created. And when I tested that, I thought that probably could be done on event 7. When COM object in the shape of DLL, that's great, and that was a problem I spoke about in process and out of process. And sometimes it happens almost simultaneously. Such a detect doesn't work. You cannot, you can't up and detect that. Well, I'm glad to see you once again. That's the same process, so why not? Well, you said that detection could be done on the registry branch, and hence is my question.
был ли опыт настраивания аудита этих людей, и это потому что накинуть сакл.
Well, you can impose SACL on that's it, and this is far from being easy. And the second thing, if SAC are being imposed on all the branches of the registry of objects, then it may generate a lot of events, and hence is the question whether CM will be overloaded with the flow. It would be overloaded, but you can use SysMo. But the same problem.
С этим правилом нет. Это правило нет в плане, если вы как-то исключаете на системе события реестра, создание set value.
Well, what about set value? Certainly, we are monitoring certain branches. Well,
Тогда вопрос, на самом деле, можно каким-то образом более низкоуровневыми фильтрами на ближе к хостам это настраивать.
we can fix it closer to the heartbeat. So that's a high severity. That's a very good detect. Okay, thank you. Thank you. Thank you so much, Vladislav, for a very interesting contribution. I have the following question. Proceeding from your experience, how often the attackers would be using COM in their attacks? I do not mean the use of some ready-made offensive malware, but using just COM objects. And a follow-up question is, shouldn't we just focus on COM and ECOM, but rather focus on their consequences? As you said, we can look at the change in the branches of the registry, some abnormal processes, and anything like that. Changes in CMD. Well, thank you so much for the question. As for what methods are being used most frequently, well, quite frequently. Not always they're using the methods that I have shown. Sometimes it might be done in the initial access as microsource. Sometimes it might be done in order to download stages. One in order to upload payload. The other one actually is being used in order to bring that into the shape that could ease the way it is being used afterwards. Whether we have to focus on COMs or fixated on COM, but it's very important to understand how it works and research in that area. Again, 9.5 thousand COM objects with enormous functionality that interact with everything, and everything rests on that. That's the reason to find some vulnerabilities and to correct them, fix them. Well, thank you. Hi, and thank you for your report. You spoke about COM, then DCOM. As a programmer, as a software developer, if I want my server to be a DCOM, do I have to do something more as a software developer? Well, every DCOM is a COM, but is every COM is a DCOM? Well, no. You have to trigger to run a proxy. The system will not marshal the data to you. Some interfaces have to be provided that would be convenient for the interaction with the remote host. And the second question, do you know whether this is configured for DCOM? So you said that there is a group of DCOM users. How can we visualize that? Active Directory users in computers? No. But is it applicable for all DCOM servers, or it can be set for every DCOM server? This is for the users who would like to launch DCOM service on another host. This is the group which determines whether they can do that or they cannot do that, as far as I remember. Thank you. Have you analyzed whether they can be done by ETV? Can you look deeper? DCRPC works through that. The network traffic, for instance, in terms of the intelligence, could be detected as well? Yep. But even if we do not go to the level of ETV, then any audit would be quite ambiguous. It's very difficult to detect that in the whole branch. In case of an integrator, that would be almost unreal. We have to look for some patterns, SVT host being created or something created in the registry. But I've not looked at some EVT providers there. And the second part was about... You said that, in fact, we can detect the final activity, the launches, but sometimes there is a network intelligence which can be done without launching a console. And ETV might be used in order to look at DCOM being triggered, so we can have a look at that at a lower level. Well, we can do that at the network level somehow, and this is a topic for another research, but I know that we can do that. We can create a COM on another machine, snapshot that, and have a look at what happens to the traffic. There has to be some interaction in terms of RPC and some other specific things. Thank you. Thank you. Thank you so much for your report. The first question is, assume a young analyst, bearing in mind the future plans, is it realistic that Russia would migrate to Linux? Should we learn more about DCOM? Would it be enough to mind just some limited features of DCOM? Well, I'm not sure about Linux, but probably for a young analyst, this is not a top priority topic. I think that this is quite an interesting thing for research. Second question. On some slides, you told us about detection and logging and bug shell execution. And you said that it could be done via AMC in order to write something on your own and detect that. Can you tell us in more detail? Because at least I understand that when I was playing with some web shell codes, every time Windows would stall it, would block that. Just any executable line would be blocked. Well, AMC detection, I mean my own AMC provider. So in the documentation there is an example of a simple AMC provider, and as soon as you register that as an AMC provider, it is uploading to the PowerShell and other processes along with Microsoft ones. So it means that you can write a rationale of detecting some malicious scripts or lines in these scripts. You can introduce them manually. Thank you. AMC helps us to work with interpretable things, because exe extension actually has been traced by the antivirus applications. Well, Microsoft determines what should be there, what should not be there. Thank you so much. Once there are no questions, I suggest that we call it a day. Thank you so much.